Hello friends, it's time again to look into your diary and add few more pages. But this time before I start, I want to ask whether all of you are healthy and doing well. Because as we know, this time the whole civilization is fighting against this COVID-19 pandemic. So many people have already died. So I request all of you, please take care of your health. And this is the time when you can put things into perspective, put your life into place. I will start with a small story. I met one of my friends today morning. He told me that, my life was like this bowl. And I had a small marble, he said to me, which I used to keep here. And it was perfectly fine. But I noticed that whenever there will be disturbances, this marble will tend to fall down. Sometimes it will fall here, if the disturbance here is fall here. And he compared this marble with his state of mind. So he said, I had the bowl, I kept the marble in a perfectly stable position. But sometimes whenever there will be little disturbance, it will tend to fall apart. Then I asked him, then what did you do? He said, I met with one wise man. He told me that, beta, nothing is bad in your life. You just got to put the bowl upside down and keep the marble here. My friend was telling me today morning, just by organizing the things in a proper manner, I found absolute stability. These days, even if there is little bit of disturbance, the marble never fall apart. So the crux of this beautiful story, in our life we have the ingredients. What makes all the difference is how you organize them. So with this small introduction, let us now straight away move to Kober's geosyncline theory. I have given you 4 points as you see here. The first one is that the main objective of Kober was to establish a relationship between ancient rigid masses and geosyncline. We have seen that Professor Emil Hogg or maybe Professor Suchard, everybody tried to do that. But Kober's relationship between ancient rigid mass and the geosyncline was more direct. That is why his theory is more acceptable. And the number 2, Kober was essentially a contractionist. I already told you in the previous lecture that the ancient land masses that Kober took, and in between he formed the geosyncline. Okay, when we will see that he tried to move these two land masses towards each other, he said that this force of movement was because of contraction of earth or the cooling. That is why he is called a contractionist, right? And then number 3, see, there are few terms, like 4 or 5 terms, which should be there in your answer. For example, these rigid masses, they were given the name cratogene or foreland by Kober. You have to use this. And then this geosyncline in between, Kober called this geosyncline as orogene. It is simple. Oros means mountain, gen means genesis or birth. So as this geosyncline in between here will give birth to the folded mountain, that's why Kober called them orogene. And then when the folded mountain range will start forming because of contraction and squeezing, then first these mountains will form slowly. These parallel ranges were given the name as Rand-Catene. Okay, and Kober said that first these Rand-Catenes will form, that is the marginal ranges, and when the force of squeeze is acute and higher, then it will completely turn into folded mountains. Okay, so you see, first Rand-Catene here and then complete fold mountain. That is it. I will later explain in greater detail. And then in this first diagram, when there is Rand-Catenes in both sides, in the middle this plane is given the name as median mass, and he called it as Juichenberg. Okay, he was a German, Leopold Kober. So these names are German names: Cratogene, Orogene, Rand-Catene and Juichenberg. Okay, in the next we should know that Kober gave 5 phases or 5 stages of the mountain building through geosynclines. Then what are these 5 phases? The first phase is called geosynclinal phase. What is this? This is a simple formation of geosyncline where we have sedimentation and gradual subsidence of the geosyncline floor. I explained to you how it will go down. So that is his first phase. See, this theory is very simple if you understand. First he said the geosyncline is developing. Then number 2, he named this phase as lithogenetic stage. Lithogenetic stage. The name itself is suggesting that lithos, that is the stone or the rock, will generate now. Simple. The geosyncline has formed, the sedimentation has happened. Now slowly that will become hard to form lithos, that is rock. So this is the stage of rock formation due to consolidation. The third stage he named as tectogenetic stage. This is a subsidence stage, and no, this is the stage when the subsidence will stop. Okay, in the lithogenetic we had the gradual subsidence. In tectogenetic the subsidence will stop, and this stage looks like a very quiet phase. Rock structure, that is fold, bedding plane, fault, etc. are formed in this stage. Okay, and this stage can also have volcanism. The fourth one is called orogenetic stage. Simple. Litho has formed, the rock has formed, tectogenetic stage has gone, that is the fault, the folds, etc. have developed. Now it is orogenetic stage, that is the actual upliftment will occur in this stage. And the last stage, that is the fifth stage, was named by him as glyptogenetic. Glyptogenetic, Glyptogenetic, glyptogenetic stage. And this is the old stage where the denudation and erosion and weathering of the folded mountain will start. So in short, this is the Kober's theory of geosyncline. Now I will help you as usual to dictate these things as to how you will write an answer of Kober's geosyncline if you have to. The theory you understood. Okay. Now I will tell you. Now I will just tell again in a very organized manner so that if you can write it down, it will be your Kober's geosyncline answer. So let us see the next slide. What is it? Yeah. So the answer we can write probably like this. The main objective of Kober's theory was to establish a relationship between ancient rigid masses, here ancient rigid masses or forelands, and the mobile zones of geosyncline. Okay, geosyncline is in the middle. Then you can write that the geosynclines were called orogen by Kober. And Kober not only attempted to explain the origin of mountains on the basis of geosyncline theory, but he also attempted to elaborate the various aspects of mountain building, their geological history, evolution and development, etc. That is why Kober's geosyncline theory is a much detailed and discussed theory. Then you can write probably, he defined the process of mountain building or orogenesis as the process which links rigid masses with geosyncline. In other words, mountains are formed from the geosynclines due to the impacts of the rigid masses or the cratogens. Understood? Then you can write that Kober is definitely a contractionist because the motive force of the movement of cratogen was because of contraction. Then you can go on writing that according to Kober, there were mobile zones of water in the places of present day mountains. He called these mobile zones of water as orogen or geosyncline. These mobile zones of geosyncline were surrounded by rigid masses, which were termed by Kober as cratogen, and these rigid masses included the present day Canadian Shield, Baltic Shield, Siberian Shield, Chinese Plateau, African Plateau, Brazilian Plateau, etc. Next, you can mention that Kober relied on a paleographic map given by Professor Emil Hogg while assuming the location of continents and geosynclines of Hogg's paleographic map. Now, in the last lecture, I gave you the Hogg's paleographic map. You must go and see that. Okay, where I have shown you the ancient Creton's ancient land masses that Hogg mentioned, like North Atlantic continent in the present days of North USA. Then I explained African Brazilian continent, okay, which will include the whole of South America and the African continent of present day. That was one single landmass that time. Emil Hogg said that, and Kober used the same. And then Indo-Australian continent, Indo-Australian Madagascar continent. This whole area was one single landmass, right? So you can refer to that picture I gave you, that diagram you can draw here. And then you can say that Kober has identified 6 major periods of mountain building. Okay, so you can follow his theory that he explained geosyncline, then we said that he was a contractionist, then we explained that he used Emil Hogg's paleographic map, then we gave that diagram. Now we are saying that everything is ready. Now he is trying to develop folded mountains, and see, this development of folded mountains will not happen in 1 or 2 years. It will take billions of years. So we will now write that Kober has identified 6 major periods of mountain building, and among those 6, about 3 happened during Precambrian period, about which very little is known. Whenever I say Precambrian, you must look into the geological time scale that I gave in the last lecture. Then you will understand where is the Precambrian era, right? So Kober said that there are 6 major periods of mountain building. I'll give you those names of those 6. So here you see, among the 6, the first, second and third happened during Precambrian. Go back to the geological time scale and match. And the 4th and 5th happened during Paleozoic era. And the names of these two, 4th and 5th orogeny, were Caledonian orogeny, see here, Caledonian orogeny and Variscan orogeny. These two happened during Paleozoic, and the last and the 6th one happened during Tertiary era, and this orogeny was named by him Alpine orogeny. Okay, so you match this name, Precambrian, Paleozoic and Tertiary, and see that when Kober explained that his folded mountain orogeny occurred. Next we go on explaining. According to Kober, the whole process of mountain building process passes through 5 closely linked stages of geosynclinal stage, lithogenetic stage, tectogenetic stage, orogenetic stage and glyptogenetic stage. Here I have given all the names to you. While explaining this, you can write in a paragraph that the first stage is related to the creation of geosynclines due to the force of contraction caused by cooling of the earth. And then the preparatory stage, or the stage of rock formation, is also called lithogenesis. The geosynclines are nothing but long and wide mobile zones of water bodies which are bordered by forelands or cratogens. While explaining this Kober's theory, you can draw these diagrams also, what you see here. So I explained this cratogen or the foreland. Okay, now you write, these upstanding land masses or cratogens are subjected to continuous erosion by fluvial processes, and the eroded materials are deposited in the geosynclines. Okay, this process of sediment deposition is also called sedimentation. The ever increasing weight of sediments due to gradual sedimentation exerts enormous pressure on the beds of geosyncline. With the result, the beds of geosynclines are subjected to gradual subsidence. See, I wrote here downward subsidence of geosynclinal bed, and that is why they are called mobile beds. Okay, so this is a beautiful aspect of geosyncline. When the sediment will gather, the beds will dip, and you can understand, okay, logically why they have given this concept that the beds will dip. Because you remember, when they found the folded mountains, they saw that the animal fossils in the folded mountains are of those animals who reside in shallow sea. Okay, I give you this linkage. You try to think that why they incorporated this idea in geosyncline, that the beds will be mobile, it will dip. Generally what we think, that if there is a water body and if the sedimentation comes, one day water will go away and the sediment will come up. But here in geosyncline, that there is a difference. The bed will dip and the shallow level of water will be maintained. Okay, so then again, if you write the answer, the twin process of sedimentation and the resultant subsidence result in the deposition of enormous volume of sediment and attainment of great thickness in the geosynclinal bed. Then the next stage is called tectogenetic stage, where the subsidence stops, and this phase looks like a very quiet phase, and the rock structure like fold, fault, bedding plains, etc. are formed in this stage. And the next stage is orogenetic stage. Both the forelands start moving due to contraction because of the cooling of the earth. The compressive forces generated by the movement of foreland together cause the squeezing of the geosynclinal bed, and ultimately the folding of geosynclinal sediment form the mountain ranges. The parallel ranges formed on either side of the geosyncline are termed as Randketten, see here, by Kober. So you understand, when slowly the contraction force will start squeezing the bed, first these Randkettens will form. These are the marginal ranges. Okay. According to Kober, the folding of entire sediment of the geosyncline or part thereof depends on the intensity of the compressive forces. If the compressive forces are normal and the moderate of moderate intensity, only the marginal sediments of the geosynclines are folded to form Randketten, and the middle portion of the geosyncline remains unaffected. Okay. This unfolded middle portion is called Juicenberg or median mass. Here you see. So simple story. It has just started folding and the compression force is not that high. That is why only the Randkettens are formed in both sides, and the middle portion is still is like a plain median mass, which is called Juicenberg. Now he is saying, if the compressive forces are very acute and large, the whole geosynclinal sediments are compressed, squeezed, and ultimately folded, and both the forelands are very close together. This process introduces complexity in the mountain, because acute compression results in the formation of recumbent fold and nappy. You remember we read about recumbent fold, nappy, overturned fold, etc. Try to link. Now we are almost done with Kober's theory, and this is the matured folded mountain ranges, and see, there is no median mass anymore. Everywhere there is folded mountain because the stress has become very acute. Okay. Now in the end, we will take certain examples from today's earth surface to show that Kober's idea of Kratogen or the median mass or Juicenberg or Randketten or folded mountain, etc. are there. So let us take some example. I will show you one map while I explain this. Let's go to the next slide. Okay. Now let us continue writing the answer. Next point. Kober has attempted to explain the forms and structures of folded mountains on the basis of his median mass concept. According to Kober, the Tethys geosyncline, see the first example I am giving, the Tethys geosyncline. Tethys geosyncline was bordered by European landmass in the north. Here you can see, I will not destroy this diagram much. This is the European landmass and the African rigid mass in the south. So in between there were Tethys geosyncline. You try to visualize. He said the north of Tethys geosyncline were the European landmass, and in the south there were rigid African mass. So this was one cratogen and this was another cratogen. The sediments of Tethys geosyncline were compressed and folded due to movements of European landmass and African rigid mass together to form alpine mountain system. Here you see I have given the names, like I will highlight. See, I have given the names like Carpathian, Balkan. So he has taken names that because of the movement of European landmass towards south and the African landmass towards north, the alpine mountain chains were formed, like the Betic Cordillera. You see here I have shown Betic Cordillera. Okay, it is in Spain. The Pyrenees, here I have given Pyrenees. The Carpathians, see here Carpathians, you will see here I have shown Carpathians. The Balkan mountains, here you can see the Balkan mountains here, etc. were formed, and also the Caucasus mountain. This is the Caucasus mountain. These were formed. So concept is simple. He took Tethys in the middle and took the cratogen, one cratogen as European landmass and the southern cratogen as African landmass, and he tried to explain that all these alpine ranges like Alps itself here, and the Carpathian, then the Balkan, then the Caucasus, then left side this Pyrenees, Betics, Apennines, then Dinaric Alps, okay, etc. were formed because of this movement. Another example that Kober gives is this Mediterranean Sea. You see, this is the Mediterranean Sea. This one, this is the Mediterranean Sea. This red color I have marked here. He is saying that Mediterranean Sea is in fact a great example of median mass between Pyrenees range in the north and Atlas mountain of Africa. You see here, this is Atlas mountain here. So he is saying in between this Mediterranean Sea, this is the Mediterranean Sea, is a good example of median mass between the northern Pyrenees mountain and the southern Atlas mountain. Okay. Then he tries to explain the Himalayan orogeny. He said Asiatic folded mountains including the Himalayas were also formed due to compression and folding of sediments of Tethys geosyncline caused by movement of Angaraland and Gondwanaland forelands. So when he is trying to explain this Himalayan orogeny, he named the northern mass here as Angaraland and the southern mass here as Gondwanaland. So you have to remember these two names when you explain Himalaya. Northern is Angaraland, southern is Gondwanaland. These two moved towards each other, and the geosyncline is the same geosyncline Tethys, which became Himalayas. And as we all know that Himalayas is a young fold mountain, so here Kober gives an example that the Tibetan plateau here, this is the Tibetan plateau, I'll mark with red. See, this is the Tibetan plateau. Kober said that the Tibetan plateau is a fine example of median mass between Tien Shan Kunlun Shan and the Himalaya. Okay, So he is trying to say something like Tien Shan, Kunlun Shan, Himalaya, these are Ranketens, because the compressive force is still working. Something like this he wanted to say. Next, and the last point about Kober, he explained that the median mass may be of various forms. For example, the median mass can be a plateau, for example the Tibetan plateau we just saw. Then next he said that median mass can also be like a plain, like the Hungarian plain between Carpathian and Dinaric Alps. You see here, this is Dinaric Alps, and in the north there is Carpathian. So between these two I have brightened, see the Carpathian dark black arrow and the Dinaric Alps here dark black arrow. In between them there is Hungarian plain, and this is another median mass. So he is saying median mass can be a Hungarian plain type, or here like Tibetan plateau type. And then he is saying that the median mass also can be like a sea, that is Mediterranean Sea between Africa and the Europe. Here you have already seen. So he is saying that median mass also can be various types. And the last stage of Kober's geosyncline is the denudation stage by fluvial and other erosional processes. Fluvial means through rivers. And the continuous denudation results in gradual lowering of the height of the the mountains. So with this, we end the discussion on geosyncline theory, starting from Hollandana and up to Leopold Kober. I hope that you understand the geosyncline approach, how it originated and how it developed, and the similarities with present day world. Thank you. Sorry, I was missing out on the most important part, which was the evaluation of Kober. So let's look into it quickly. At the beginning I told you that almost all the geosynclinal theories will have the same kind of criticism. Let us see here. In the first point we see that Kober used Hogg's paleographic map. This paleographic map I provided in the last lecture. There you can see that Hogg used cratons, the ancient landmass, as big as, including Africa here, Indian landmass here, and Australia here. So one craton was this big, and Hogg used I think 6 or 7 cratons like this, and he said that these cratons developed during Mesozoic era, but he could not explain that where did they come from and where did they go. And as Kober used this paleographic map, so Kober also could not explain these immense land masses. This is first criticism. The second one, Kober's geosyncline theory explained the east-west expanding mountains very well, like the Alps, the Himalayas, Caucasus, etc. But this theory failed to explain north-south expanding mountains like Rockies and Andes. So this remains a drawback. The third point is Kober almost always systematically moved both the cratogens simultaneously. Like we saw, if this is a cratogen and this is the cratogen, and in the middle there is a geosyncline, Kober almost always moved both the cratogens towards each other to form the folded mountains. But later theories showed that it is not necessary that both the cratogens, or both the plates rather, will move simultaneously. Although it can sometimes, but not always. So this is another point of criticism. And the last but not the least is the force of contraction. Later theories showed that the force of contraction cannot give rise to immense mountains like Himalaya, which is almost 9 kilometers in height, or maybe Rockies or Andes, etc. Simple cooling force of contraction cannot give rise to these kind of massive mountains. There must be something else, which will be dealt with in continental drift and plate tectonics theory later, that what was the actual force for this movement. So here I end the discussion. Please like, share and subscribe. Thank you.